So here is my messy picture of a muscle. So let me take this in. So right here, this is going to be the muscle, this big cylinder. And so outside of the muscle, surrounding it is going to be connective tissue. And this layer of connective tissue is going to be called epimyosin. And then if you look at the smaller one right here, the smaller cylinder, it's labeled A at the top, and it's going to be our fascicle. And the fascicle is also surrounded by connective tissue. Let me keep the picture up so you can see. So this connective tissue is paramyosin. So then inside the super small one right here is going to be another cylinder that I've labeled B, and that's going to be our muscle fibers, also our muscle cells, which also is going to have connective tissue surrounded by it. So now this connective tissue is going to be called endomyosin. So you have the cylinders that represent all of that. So then these lines right here, as you can see inside the cylinder, I've got a close-up picture of it, of what those lines are inside the muscle fibers. So it looks like this, and they're called myofibrils. The long sticks are myofibrils. Now inside are myofibrils. You see the stripes or whatever? This is also a skeletal muscle, so that's why it has stripes on it. But the stripes are going to be your sarcomere. That's why you have that. And in between the color labels, and on here it was labeled D. But I have drew a close-up picture so you could see what the myofibrils and the sarcomere kind of look like, just to get a close-up because it's a lot than one. So now that we know what the muscle cell looks like and what's inside of it, we can talk more about the sarcomere and then the small pieces of everything, and then we can piece the contraction together of a muscle. So the sarcomere is composed of thick and thin filaments, and each one has a job. So the thin filament is going to be composed of something else, which is our actin. And then the thick is myosin, and then our thin is going to be actin, tropomyosin, and tropin is going to be composed of those. So the thick and thin filament and what they have inside of it, the actin, myosin, tropin, and tropomyosin, are very involved in the contraction of a muscle. So each sarcomere at each end of these things, these stripes, is going to be something called a Z line, each end of each stripe, at the end of each sarcomere, and they, when contracting, are going to pull together and pull everything in the middle to each other. So when contraction is happening, actin and myosin are going to be relaxed because they're right here, but they're still going to want to pull together. They want to be together. So this is known as a sliding filament, when the Z lines are going to come together, causing the thick and thin filaments to slide past each other, and then actin and myosin can overlap. So when all of this comes together, so the tropin and tropomyosin are going to block the actin and myosin from coming together. They're going to stop them from coming together. But the blockage can be stopped, and something that can stop it is going to be our sarcoplasmic reticulum. And the sarcoplasmic reticulum holds a lot of calcium. It holds a lot of calcium, but we're also going to need ATP to help. So now that we have our little definitions and pieces together, we can put it all together. So to start the whole process of contraction from beginning to end, starting relaxed and ending relaxed. So you're going to have an action potential that is sent from your brain, and the action potential is going to run to a motor neuron, and the action potential is going to cause acetylcholine to be released. I think I said it right. So when this is released, it's going to release from the end of a neuron until it crosses over with our synapse, and then it's going to bind with receptors of our muscle. That was a lot. Okay, so then the action potential is going to form in the muscle. After all of that's happened, the action potential can be in the muscle, and then it can travel through our membranes inside our muscle, so our sarcomere and all of that has the mitochondria and everything, the cells, so it's going to have everything a cell has. It's going to have membranes, and it can travel through our membranes from our membranes, then it will go to our T-tubes. This will allow calcium from our sarcoplasmic reticulum that has been saved up for us. So the sarcoplasmic reticulum saved up all this calcium for us. The T-tubes are going to cause that to be released. This is going to be released now. The calcium is going to be released, and now the blockage that we talked about before of the actin and myosin is going to be stopped now. So this is how it's going to happen. The calcium is going to bind with troposin, which when the calcium binds together, it can change the shapes. So it's going to change shapes and bind together, the calcium and the tropicin. And then the tropicin is going to tell, tropomyosin to move off the binding of the actin. So it'll move off the actin. Now the actin and myosin, there's nothing in the way, and they can bind together. So when the actin and myosin get together, the myosin head actually, so they each have their ends, the head is going to use ATP to move to active position. So the muscle's resting. Now the myosin head will, use ATP and start to move and create an active position in your muscle. So this pulls the actin to the middle of the sarcomere. So like everything is just pulling together. So it's relaxed and everything is just pulling together and contracting. So this process is going to be repeated, but first the myosin head release. So the myosin head is going to release, and then actin and myosin, they're still together, but the myosin head is going to release, and then it's going to use ATP to move from resting to active position, pulling everything together. Then the myosin head is going to release, and then again and again. So once the action potential is over and all of the, that process goes through a couple times, however many times it needs to go through, the action potential comes to an end. Now the calcium that we used, it's not gone. It can go right back to our sarcoplasmic reticulum. But that uses ATP, but that's okay because we can make more. But our calcium just can go right back and being stored and gathered up in our sarcoplasmic reticulum. So now, what about our tropin and tropomyosin? They are going to go back to the myosin binding site on the actin filament. They're going to go back to blocking and kind of back to how it was before in the way until another contraction is going to happen. But until that happens, the muscles are going to go back to being relaxed, and the actin and myosin are going to be relaxed, but they're still going to want to bind together. And then the process just happens. Like right now, my hand's moving. This whole process is just going through over and over again to cause our muscles to move.